Hi class, we're going to go over our midterm 2 review. So we started with chapter 4.1, and this was on exponential functions. So we started with functions that look like a raised to the x, where a is a real number, and it had the property where a of 0 equals 1, and a raised to the 1 equals a, and a to the negative 1, this is 1 over a. All right, so important things to know with these types of functions, we need to know how to graph and transform them. And this is with our internal and external addition. Oops. As well as our scaling. All right, and we also learned the compound interest formula. So the compound interest formula can be written as a of t equals p times 1 plus r over n all raised to the n times t power, where n is the number of times you compound your interest per year. All right, and then we moved on to section 4.2. And this was on the natural exponential function. And so with this was with the letter e to the x, and it was basically the same as everything in section 4.1, except we're using this constructed number e. And we also learned about continuously compounding interest. And this formula is a of t equals pe raised to the rt. And this section was pretty short, and then we moved on to section 4.3. And this was on the logarithmic function. And a logarithmic function is the inverse of an exponential function. Which means that if we have log base a of x equaling y, this is equivalent to a raised to the y equals x. And we learned about the difference between the logarithmic and versus exponential forms. Which, as we can see above, this log a of x equals y, that's a logarithmic form. And this a raised to the y equaling x, that is our exponential form. And then we also learned the properties of logs. So we had that log a of 1 equals 0. Log a of a is a. Log a of a to the x is x. And a log of a of x also equals x. And we also learned how to graph and transform graphs of logarithmic functions. And then we learned about the common log, which is log base 10, and we just write as log. And we also learned about the natural log, which is log base e, and we write that as ln. And then we moved on to section 4.4, which is laws of logarithms. So our first law was that log of a times b is log sub a of a plus log sub a of b. Our second law was log sub a of a over b. This is log sub a of a minus log sub a of b. And then our third law is if we have log sub a of a raised to the c, this is c times log sub a of a. And we learned how to expand and combine expressions, logarithmic, we also learned the change of base formula. And this was if we have log of b of x, this is log of a of x over log of a of b. All right, and from there we moved on to section 4.5, which is on exponentials and logarithmic equations. And so here we learned that because exponentials and logarithms are one-to-one, we can use them to solve equations of the form like a to the x equals a to the y. We know that this will imply that x equals y. We also learned how to solve for x. And one of the ways that we learned to solve for x were quadratic type logarithms or exponentials. So for example, if we had e to the 2x plus e to the x minus 6 equaling 0, if we let a equal e to the x, this means we can rewrite this as a squared plus a minus 6 equals 0. And then we could factor, and we would have an a plus 3 times an a minus 2. And then we would plug in our original a. So we would have a to the x plus 3, oh, this equals 0, times, oops, e to the x minus 2 equaling 0. And then we just can solve for when one of these equals 0, and that will give us our solutions. All right, and on that note, we need to remember to check the domain of original equation when solving logarithmic equations. Because otherwise our solutions might be outside of their domain and then they won't work. So we can only use solutions that fall within the domain. And we also learned how to solve for specific variables in application problems. And then our section 4.6 was very focused on these application problems. And this is where we looked at modeling with exponential functions. So first we learned about doubling time, which was n of t equals n naught 2 raised to the t over a. Then we learned about relative growth, which was n of t equals n naught e to the rt. And then we learned about radioactive decay, and so there were two equations with this. We had m of t equals m naught 2 to the negative t over h, where h is half-life. And then we had m of t equals m naught e to the negative rt, and it's negative because we're having decay, so everything is getting smaller, where r is the natural log of 2 over the half-life. And then our last equation we learned about was Newton's law of cooling. And this was T of T equals T sub S plus D naught E to the negative KT. All right, so these were our main application problems that we looked at, and we should be able to solve for specific variables within them. And then for the midterm itself, you will have 2 hours to complete it at any time on Friday. So you just have to make sure that when you've opened the exam, you're ready to take it, because you will only have that 2-hour window. And there should be 10 problems. It's very similar to the first midterm, 10 problems where some of the problems will have smaller parts. And you'll need to scan and upload it just like normal. All right, thanks class.